Alrighty folks, today we are doing something a little bit different in terms of our drift car project. So where we are with the car at the minute, as you'll have seen in the last few installments, is that we have the motor pretty much installed. I got to do a bit more than that, bolting it in and so on. Got, I think, all the stripping done, fortunately now. And we are going to be looking now at how we handle some of the, some of the ideas that I have for handling the instrumentation. Just before we get into that, I just want to clarify one thing that's coming up in the comments fairly regularly regarding this project, and that is the, I suppose, rather brutal way that I remove some of the components. Now, I've had this car since January of this year, and since then, for pretty much 9 months now, I advertised the car, all the parts in it that I wouldn't need. Nobody was interested. I then said people could have the parts for free if they came and took the parts out. Guess what? Nobody interested. I then said on the last few bits I'd take the parts out and they could take them for free. Give you one guess. So just to clarify that point, I'm not deliberately wasting potential revenue here. Alright, now that we have that cleared up, let's go take a look at what we're doing with the instrument cluster. Here we have the instrument cluster from our E46. It's pretty much standard. It's got fuel gauge, speedometer, tachometer, fuel economy gauge, temperature, and various warning lights. Now these E46 instrument clusters are pretty much a kind of a hybrid. And what I mean by that is that some of the signals are analog or digital signals, and some of them come in on the CAN bus. So just taking a look at the wiring harness here at the back, you'll see signals like the oil pressure warning light, the alternator warning light, the ABS warning light, and so on, are actually just grounded signals. So for example, if we ground this wire here, the oil pressure warning light comes on. If we take the ground away, the light goes off. And some of the signals, like for example the tachometer, fuel economy, the temperature, and some of the warning lights are actually CAN bus driven. And in order to send some CAN bus signals to the cluster, I've just got a CAN bus shield on an Arduino Dewey here. I got two of them set up because I was logging some of the CAN messages and just doing a bit of development work with that. So I'm gonna go ahead here and just turn on basic 12-volt power to the instrument cluster. And you'll hear the gauges go to their home position. So this is what you get when you turn on the cluster. Obviously I've got the backlight turned on as well here just to aid viewing. And what I'm going to do now is I'm going to plug in one of these Arduinos here, and we should be able to see what happens when we start sending it some CAN messages. So we're sending RPM, we're sending temperature to be just on the first quadrant, and so that's basically, we're sending a few extra messages as well regarding turning off the check engine light. We can turn the check engine light on and off with the CAN messages. There's a few other lights we can do on there as well, but this is just sending one stream of messages here. And if we want to get the speedometer to work, this is where this is a kind of a hybrid cluster. We need to send this a 10-volt square wave. So Let's on the oscilloscope and the signal generator. We turn on the signal generator, and here goes the speedometer. You can see the acceleration is not exactly mind-bending. Oh, there we go, we got a burst of speed. And I can change the speedometer speed by increasing the frequency of the pulses, you know, right up to where we're basically tearing up the highway. And the odometer is incrementing. We can turn our frequency back down. Something a bit more sedate. So basically we can also send commands over the CAN bus. Now that we would have the speedometer signal valid, we can send signals to the MPG meter. That's a rate of change of 2 values. I'm going to put a link in the description to a guy's blog that's been doing a lot of work with the E46 instrument clusters and other BMW instrument clusters. They were using these little kind of CAN bus shields from SparkFun, but I kind of got used to the I got more used to the Dewey based ones when I was working on some of the Chademo stuff last year, so I just kind of copied the messages across and put them in there, and as you can see, it's working quite well. I'll just turn off the bench light here. You know, you can pretty much see that there's a lot of data that we can send to this cluster in fairly simple messages. There's no checksums or anything like that. So my plan then is to maybe get a more modern cluster, like from an E90 or an E87, because they basically, from what I can read, only have 6 wires connected to them: power ground, CAN high, CAN low, and 2 wires for an external temperature sensor. So all of the gauges, the lights, everything on those instrument clusters works by CAN messages. And there looks to be some good developments going on there for decoding what those messages are. And I suppose the real point here is our new inverter is going to have CAN on it, and we will be able to transmit messages about inverter parameters, so motor RPM, temperature, status. You know, we can use the check engine lights, we can use temperature warning lights, we can use all kinds of the facilities that's on a very cheap, like 20-30 euro instrument cluster for doing displays. So okay guys, that's about it. A little bit of something different today for you, and I hope you've enjoyed it. I hope you're enjoying the project. We've got a lot more stuff to do on various other elements, and I've got to get working on the Panzer again for some of the fast charging stuff. So don't forget to check me out on Instagram at EVBMW. Don't forget to subscribe. Take a look at my Patreon, link in the description, and I'll also be linking in the description the forums and so on, where I've gotten some of the info on the BMW CAN messages. And if you have any other info or questions that you'd like to ask, pop a question down in the comments, and we'll see you all next time.